Hello everyone. Today we are going to discuss about the Thevenin's theorem lab experiment theoretical calculations. Let's see how to calculate the theoretical calculations of the Thevenin's theorem. So before going to the theorem, first we'll see the statement of the Thevenin's theorem. It states that in any linear bilateral complex network having more number of elements, the entire network can be replaced with an equivalent circuit called as a Thevenin's equivalent circuit, which is consist of the Thevenin's equivalent voltage that is connected in series with the Thevenin's equivalent resistance. Okay, now let's see the practical diagram of the Thevenin's theorem. This is a circuit diagram, okay, which is consist of there are different elements, and this ammeter is used to find the current passing through this load resistance. Okay, now if you see the equivalent circuit, this equivalent circuit consists of the one voltage source. The name of that voltage source is called as the Thevenin's voltage that is connected in series with the RTH. Okay, and this is the ammeter. This ammeter is used to find the current passing through this load resistance. In the Thevenin's theorem, we will convert this total circuit into this simple equivalent circuit. And here, this VTH is called as the Thevenin's voltage. There is a procedure to find the VTH, and there is a procedure to find RTH. Okay, after finding VTH and RTH here in the equivalent circuit, we will find out IL here. We will call it as IL dash here. Okay, this is the equivalent circuit of the given circuit. This is the equivalent circuit. Okay, in this, we have to prove that in the given circuit, the current passing through the load resistance is IL. Okay, after finding the equivalent circuit, again we have to find out the current passing through the load resistance. That load, the current passing through the load resistance, we are assuming that IL dash. So finally, this IL is equal to IL dash. Then we can say that Thevenin's theorem is verified. Okay, now let's see how to verify the Thevenin's theorem theoretically, and we will find one by one parameter. Okay, finally we have to verify IL should be IL in the given circuit. The current passing through the load resistance is IL, and after finding the equivalent circuit, the current passing through the load resistance is IL dash. So finally IL should be equal to IL dash. Let's see whether it is verified or not. Okay, so here we have to find out first IL theoretically, that is a load current of the given circuit. After that, VTH, Thevenin's voltage at 15 volts, 20 volts, 25 volts. Again, after finding the VTH, we will find out RTH theoretically. After finding the RTH, we will find IL dash theoretically. Okay. Here, after finding IL, VTH, and RTH and IL dash, we will see whether IL should be equal to IL dash or not. IL is equal to IL dash or not, that we have to verify. Okay, now let's see the theoretical calculations. First, to find the IL. Okay, to find IL, this is the given circuit. In this, supply voltage is 15 volts. Here, supply voltage is 15 volts here. Okay, supply voltage is 15 volts. For the 15 volts, we have to find out the current passing through this branch, that is IL. Okay, now I'm applying KVL. Applying KVL at loop 1. If we apply KVL at loop 1, assume that in loop 1, I1 current is flowing. Assume that in loop 2, I2 current is flowing. Okay, now let's apply KVL at loop 1. If we apply -2 plus 15 is equal to 2.2 into I1. 2.2 into I1, but for this 2.2 kilo ohm resistor, as it is a common resistor for loop 1 and loop 2, and both the currents are flowing in the opposite direction. That's why here 2.2 into I1 minus I2. If we simplify this, we will get 4.4 into I1 minus 2.2 into I2 is equal to 15. It is equation number 1. Next, if we apply equation KVL at loop 2, if we apply KVL at loop 2, in loop 2 there is no source, that's why 0 is equal to 1 into I2 plus 2.2 into I2 Let this common resistor, that is 2.2 into I2 minus I1. Now, if we simplify this, we will get minus 2.2 into I1 plus 5.4. 5.4 into I2 is equal to 0. This is equation number 2. From equation number 1 and 2, we will get I1 is equal to 4.28 milliamps and I2 is equal to 1.74 milliamps we will get if we solve equation number 1 and 2. From this we can say that IL load current is equal to the current passing through this branch is I2 that is equal to 1.74 milliamps. Okay, IL load current value at 15 volts is 1.74 milliamps. Now let's say at 20 volts, if we apply the 20 volts here, if we apply the 20 volts, now the same, we will take I1 current is flowing in loop 2 and the I2 current is flowing in loop, I1 is in loop 1 and I2 is in loop 2. If we apply KVL, apply KVL in loop 1. If we apply KVL in loop 1, we will get here 20 is equal to 2.2 I1 plus 2.2 into I1 minus I2. If we simplify this, we will get 4.4 into I1 minus 2.2 into I2 is equal to 20. This is equation number 1. Next, if we apply KVL in loop 2, in loop 2 there is no source, that's why 0 is equal to, we will get 1 into I2 plus 2.2 into I2 plus we will get 2.2 into I2 minus I1. We simplify this, we will get minus 2.2 into I1 plus 5.4 into I2 is equal to 0. This is equation number 2. Okay. From equation number 1 and equation number 2, we will get I1 is equal to 5.70 milliamps. If we calculate the equation number 1 and 2, we will get I1 is equal to 5.70 and I2 is equal to 2.32 milliamps. Here, the current passing through this load resistance that we are assuming that IL. Okay, the current passing through this RL is I2. So from this we can say that IL is equal to, that is I2 is equal to 2.32 milliamps for the voltage of supply voltage is 20 volts. Now let's see for the voltage is equal to 15 volts. The supply voltage is 25 volts. For the supply voltage is 25 volts. Assume that in this I1 current is flowing and assume that in this I2 current is flowing. Okay. Apply KVL in loop 1. If we apply KVL in loop 1, we will get the final equation 4.4 into I1 minus 2.2 into I2 is equal to 25. This is equation number 1. Now in loop 2, if we apply KVL in loop 2, we will get minus 2.2 into I1 plus 5.4 into I2 is equal to 0. This is equation number 2. Okay, here from equation number 1 and 2, we got I1 is equal to 7.13 milliamps. and I2 is equal to 2.90 milliamps. Here, the current passing through the load resistance we are assuming IL. So the current passing through this branch is I2. So from this we can say that load current is equal to I2. That value is 2.90 milliamps. Okay, like this we will find out the load current for the given circuit for the 15 volts, 20 volts and 25 volts. Now let's see how to find ETH. To find the VTH, we will open circuit the load resistance here. Open circuit the load resistance and find the voltage across this open circuit terminal. For this, we are applying initially 15 volts. Okay. So this to find out VTH, this total circuit can be converted into open circuit the load resistance and find the voltage across this open circuit terminal. Assume that open circuit terminals are A and B. Okay. Here the voltage across this open circuit terminal is nothing but VTH. Assume that here we are taking 15 volts of supply voltage. Okay, assume that in this I1 current is flowing, in this I2 current is flowing. Okay, instead of that, we'll do one thing. Just don't take the loops here. Okay, here, what is the current passing through this loop? The current passing through this loop is 0 as it is a open circuiting. As it is open circuited, the current passing through this loop is 0. So whatever the voltage appear across this voltage, the same voltage the same voltage appear across this AB terminals because this resistor is invalid as it is a open circuited. Now let's find the current passing through the in the loop 1. To find the voltage across the 2.2, first we need to find the current here. To find that, here, to find the current I, the formula is I is equal to V by R. Okay, what is the V here? V is 15 volts. Now let's find out the R value. Here, from this we can say that 2.2 and 2.2, R is equal to total resistance, R is equal to 2.2. In this loop, we are finding the current in this loop. As the current is same, these both are connected in series. 2.2 plus 2.2 is equal to 4.4. It is a 4.4 kilo ohms. Okay. Now, if we take R value is equal to 4.4, 15 divided by 4.4, we will get 3.40 milliamps. 3.40 milliamps. Now I am finding the voltage across the 2.2 kilo ohms. Okay, the formula is I into R. Okay, as a 2.2 kilo ohm and 2.2 kilo ohm are connected in series, the current is same. That current is 3.40 into the resistance value is 2.2. If we calculate the voltage across 2.2 kilo ohm, 3.40 into 2.2, we will get 7.5 volts. From this, we can say that VTH, Thevenin's voltage, is equal to voltage across 2.2 kilo ohm is equal to 7.5 volts. For the supply voltage is 15 volts. Now, let's say for the 20 volts and the 25 volts. Okay, first we'll see the for the 20 volts. If we apply the 20 volts here, assume that is A and B terminals. Okay, the whatever the voltage appear across this VTH, this open circuit terminal is nothing but VTH. Here we are applying 20 volts. Okay, here we know already the resistance value we know. First, to find out the voltage across the 2.2 kilo ohm, first we need to find out the current I. I is equal to V by R. Okay, what is the V value here? V value is 20. R value, as we know already, these two are connected in series. 2 plus 2 plus 2 plus 2, that is a 4.4. We will get 20 divided by 4.4. If we calculate, we will get 4.54 milliamps. 4.54 milliamps. Okay, voltage across 2.2 kilo ohm. If we calculate, the formula is I into R. Okay, already we know the current value I is equal to 4.54 into the resistance value is 2.2 kilo ohm. 4.54 into 2.2, if we calculate, we will get 10 volts. Okay, so from this we can say that voltage VTH is equal to voltage across 2.2 kilo ohm is equal to So 10 volts. Okay, as this resistor is invalid, the same voltage we can take it as a VTH. Okay, now this is the voltage VTH at, if we apply the 20 volts, we got 10 volts. Now let's apply the 25 volts here. If we apply the 20 volts of the supply, okay, assume that it is a terminal A and it is a terminal B. The voltage appear across this A and B terminal is nothing but VTH. If we apply the 25 volts, we will get I is equal to same procedure, I is equal to V by R. But here voltage we are taking here is 25 and R value we know 4.4. If we calculate 25 by 4.4, we will get current is equal to 5.68 milliamps of current is flowing. Now, if we calculate the voltage across 2.2 kilo ohm is equal to, the formula is I into R. I is equal to 5.68 into R is 2.2. If we calculate this, we will get 12.5 volts. Okay, here VTH is nothing but voltage across 2.2 kilo ohm. Here it is 12.5 volts. From this we can say that voltage across the 2.2 kilo ohm is nothing but VTH, because this resistor is invalid as it is an open circuit. The same voltage we can take it as a VTH here. Okay, VTH for the 15 volts, 25 volts, 25 volts we calculated. Now let's find out the RTH here. To find out RTH, this is the given circuit, and this total circuit can be converted into here. To find out RTH, the procedure is open circuit the load resistance and the short circuit the voltage source, and find the resistance between these two terminals, RTH. Okay, we know these two are connected in parallel. The total resistance R is equal to 2.2 into 2.2 divided by 2.2 plus 2.2. As these two resistors are connected in parallel, if we calculate this, we will get 1.1 kilo ohms. Okay, now this 1.1 kilo ohm, this 1.1 kilo ohm that is connected in series with 2.2 kilo ohms. Okay, here these two resistors are converted into one single resistor by using the parallel operation. We got 1.1 kilo ohm. Next 1.1 kilo ohm that is connected in series with 2.2 kilo ohm. If we calculate here RTH, we will get 1.1 plus 2.2, we will get 3.3 kilo ohms. Okay, this is the procedure to find RTH. The RTH value we got 3.3 kilo ohm. Okay, so this is the table. In the table 3.3 kilo ohm we have to enter. Okay, RTH value for the given circuit is 3.3 kilo ohm. Next, calculate IL dash. Okay, we calculated IL and we calculated VTH and we calculated RTH. Finally, the last step is to find out the IL dash at VTH value is equal to 7.5 volts. Here, the Thevenin's equivalent circuit consists of Thevenin's voltage 7.5 volts that is connected in series with RTH. Okay, it is a VTH value. VTH is equal to 7.5 volts and the RTH value is equal to, and the RTH value we got that is 3.3 kilo ohms. 3.3 kilo ohms. Now, here if we find the IL dash, assume that here current passing through this branch is IL dash. If we find the IL dash, the formula is VTH divided by RTH plus RL. Okay, VTH value we know already, that is 7.5 volts divided by RTH value is 3.3 plus RL is 1 kilo ohm. Okay, if we calculate the above value, we will get IL dash is equal to 1.74 milliamps. For that, Thevenin's voltage is equal to 7.5 volts. Okay, now let's calculate the remaining values of the IL dash. Here it is the current passing through this branch is IL dash. Here VTH is equal to 10 volts. and the RTH we know already, that is 3.3 kilo ohm. Okay, if we calculate the IL dash here, to find out IL dash, the formula is VTH divided by RTH plus RL. As we know already, the VTH value is 10 divided by 3.3 plus 1. So from this we can say that IL dash is equal to, if we calculate the above value, we will get 2.3 milliamps. So this is the IL dash value with VTH is equal to 10 volts. Now let's calculate the VTH value at 12.5 volts. So here it is 12.5 volts. You know already the RTH value is equal to 3.3 kilo ohm, and this branch current is IL dash. To find out IL dash, the formula is VTH divided by RTH plus RL. Here VTH value is 12.5 and 3.3 plus 1. If we calculate IL dash value, we will get 2.90 milliamps. 2.90 milliamps. Like this, we will calculate the IL dash. If you know VTH value and RTH value, we can find out IL dash by using simple Ohm's law. Okay. Now, we'll summarize whatever the values we got up to now. This is the given circuit. Okay. This is the equivalent circuit. In the given circuit, we calculated the IL value for the different voltages. That is by taking the 15 volts, 20 volts and 20 volts we calculated. And it is the VTH value and it is the RTH value. Okay, the current passing through this branch is IL dash. Okay, now let's see whatever the values we got. This is the equivalent circuit for the given circuit. Whatever the, if we summarize this, for the 15 volts, 25 volts, 25 volts, we got these values. Okay, here if you see the IL and IL dash value here, IL is equal to, we got 1.74 and IL dash is also we got same 1.74. Here also, if you see the IL value at 20 volts, 2.32 and 2.32. Here also, if you see the IL value at 25 volts, 2.90 and IL dash value is 2.90. From this, we can say that IL is equal to IL dash for the different supply voltages 15 volts, 20 volts, 25 volts. From this, we can say that hence the Thevenin's theorem is verified theoretically. Okay, in the next class, we will see how we will verify the Thevenin's theorem practically. Okay, this is about the today's session. Thank you everyone.